The ground we stand on accounts for only 30% of the Earth's surface. So what about the rest? Well, that other 70% is our world ocean, which to many of us land dwellers may seem like a foreign concept. An intangible body of water largely separated from our day-to-day lives. But in reality, the ocean is the one common link that connects us all. The food we eat, the air we breathe, the storms we ride, and the economies we build are all dependent on our world ocean. On this podcast, we will dive into emerging markets, innovative technology, and conservation efforts to shed light on the ocean, the other 70%, that enables us to have a footprint, a home, and a life on Earth. The other 70% is brought to you by Nortec. As ocean enthusiasts, researchers, and technologists, we are on a mission to make an impact through innovation, exploration, and activism above and below the surface. Help keep us exploring by subscribing on your podcast platform of choice. Hello to everyone out there listening, and welcome back to this week's episode of The Other 70%. I'm your host, Nevin DeParlo, and today we will be hearing from a well-known ocean conservation group, the Ocean Cleanup. Their lofty goal to remove 90% of plastic from the ocean has received attention worldwide. To accomplish this goal, the organization is developing innovative technologies to trap plastic floating in ocean gyres, such as the Great Pacific Garbage Patch. Large U-shaped barriers are used to catch and remove the trillions of pieces of plastic currently littering the ocean. Creating these technologies requires a team of technical experts, including lead computational modeler Bruno Sainte-Rose, our guest for today. In this episode of The Other 70%, Bruno breaks down the Ocean Cleanup's mission, how modeling comes into play in developing a successful solution, and the ways we can make a difference in the health of our oceans. Without further ado, let's dive into today's episode with Bruno. Bruno, welcome to The Other 70%, a podcast presented by Nortec, and we're super happy to have you here.
Yeah, thanks for having me.
Yeah,
Looking forward to the discussion.
Me too. Yeah, it's going to be a good time. So for those of you who may not be familiar, I guess, with ocean pollution and ocean plastic pollution in particular, would you be able to just provide a little bit of background, into what the Ocean Cleanup is doing and why it is so important, just at a high level?
Yeah, so as some of you know, the ocean pollution is something that is quite scary. One must say. There is an estimation of several million tons of plastic entering the ocean every year. So basically, as you know, plastic doesn't go away by itself. It takes hundreds or even thousands of years to decompose into something that won't harm the environment anymore. But in the meantime, for all those years, it will be there, and if nothing is done to remove it, then it will do its harm for all those years. And at the Ocean Cleanup, we are actually targeting two types of ocean plastic pollution. Is the what we call the legacy plastic pollution, which is the plastic that has been floating around in the so-called garbage patches, which are regions of the ocean where plastic accumulates. And these regions are located a few thousand miles away from the coastlines. It's really far from any kind of civilization, and it's quite striking to see that like the natural forces of nature end up accumulating this plastic there. The most known area is the Great Pacific Garbage Patch, which is located halfway between Hawaii and California, and that's our primary location of operations. And there we are developing floating technologies to clean this plastic. And so that's the legacy pollution. And on the other hand, I mean, we can keep on cleaning up, but if we don't close the tap, then the plastic will keep on entering those oceans. So that's why 1 year ago we revealed the other side of the project, which is the rivers project, where we are actually building machines that are able to remove the plastic from river mouths. And let's say that the main idea behind the ocean cleanup is to do it in a smart way and work with the forces of nature to make it happen. And we understood that for example, for rivers, the river is a natural way of plastic to be accumulated. So bringing the plastic from land into those rivers before actually being dispersed again once reaching the ocean. So that's why we're targeting really rivers specifically. We're not going, let's say, close to the shore, but directly in the rivers. And then for the oceans, our idea is to also sort of follow the current, because where the plastic accumulates, then anything that will somewhat follow the current, so which has a very small relative velocity to the current, will also accumulate where the plastic is. So yeah, that's the main idea, is to as much as possible try to work with nature to make the cleanup happen. Mm-hmm.
And it sounds like it's a multi-step or multi-pronged approach, right? Because I think on land, a lot of people actually see pollution, right? Maybe if you're around some of the really heavily polluted rivers, you can see the plastic floating down the river from the shoreline. But the ocean is kind of like out of sight, out of mind for a lot of people. They don't really understand or can't comprehend how much plastic is actually floating. And I think one of the things that you guys advertise is that there's roughly 5 trillion individual pieces of plastic floating in the world's oceans.
Yes.
And that's something that, again, being out of sight, it's really out of people's mind. Maybe they drop a piece of trash on the street and they have no idea where it ultimately ends up, and a lot of it does end up in the ocean.
Mm-hmm.
Just to give some more context, you mentioned the 5 main garbage patches that are floating in the gyres, right,
Mm-hmm.
in the world oceans. Can you provide some context into how large those actually are? Like specifically, I guess, the Great Pacific Patch, compared to countries or states.
So the Great Pacific Garbage Patch, so our estimation of the area where the density of plastic floating is above 1 kilogram per square kilometer, we estimate that to 1.6 million square kilometer.
Wow.
So that's basically 3 times the size of France, for example.
Yeah.
But there is also a little bit of a false image. I wouldn't say fake news. That at some point they were calling it the plastic continent. I mean, that's totally untrue, because it's not a location where you can actually walk on. But
yeah.
it's rather to highlight the fact that if you go, let's say, a few hundred miles away from the coastline, then the density of plastic that you can find floating at the surface will go down. And then once you get close to those conversion zones, I mean, it's a matter of currents. I mean, how the currents are shaped make any floating object sort of concentrate in a specific location. There you see the density of plastic rising, and it's really very striking that you're so far from land. I mean, the closest human beings that are just flying above it once in a while is the International Space Station. And then you see like very like big objects and also like common goods that you can find on land that end up like let's say 5 to 10 years afterwards end up there and are doing their arm so far away from their source. And as you said, one of the biggest issues with what we are doing is that we are not cleaning anyone's let's say territories in a way. Obviously for rivers we do, because we have to install those rivers in countries and for municipalities, but for the ocean it's basically no man's land or no man's ocean, so to speak.
Right.
And that's also where like the having such an outreach is so important to us, because obviously we are not doing neither business to customer nor business to business approach. We're doing a business to world approach, where it's actually like the world's support that will actually allow us to reach our goal.
And so it's sort of in summary on just the general process of how this works and how we're all connected on land is that you're walking down the street, you drop a piece of trash, your trash gets littered somehow, makes its way, either directly off of the coast and into the ocean, or outflows through rivers, which are, what are considered the arteries, I guess, of ocean plastic pollution. And then can you explain a little bit more about how the actual patches form and what the currents do to influence where they form?
Yeah, so as you perfectly pictured it, so basically if you drop a piece of plastic on land, then you have what is called the catchment area, which is basically the let's say the area that if there is a rain or anything that will start transporting this plastic, will make it fall in a river. And then so you can be like in the middle of a continent, you drop something and it ends up in the river. So once it's in the river, it can sometime end up on the bank of the river, but then still, I mean, the river is always flowing towards the ocean. So even if it's on a bank, then it will take maybe a few months or a few years, then it will eventually end up at the river mouth. And then at the river mouth, you add a few more a little bit more time, because it can also happen that when you're in the coastal area, you have again the beaching process. You have some waves that may lead your plastic to beaching, and then after some time, if your plastic is still floating, because one should say that not all plastics are actually floating. You have a good a fair proportion of plastic that directly sinks. Like once it reaches the river, it will just sink. And then if the plastic is still able to float, then it will be trapped into strong currents, sort of highways, like if you keep like kind of the traveling metaphor. Right. Highways like the Gulf Stream, the Kuroshio current, that is the one that you have in East Asia, and there it will be driven really far offshore, and there you have what is called the convergence zones, which are created by what's called the geostrophic currents. So it's basically the result of the interaction between the atmosphere and the current in very deep water that will create kind of whirlpools. If you would be very trying to make
right.
it sound as familiar as possible.
So just a circular current, basically.
Yeah, kind of a circular current, and
there's
what
no
also
way
matters
for the garbage
is that it's circular I mean, it's between quotes because it's if you see it as if you average it over time and in space, then it actually looks circular, but it's more a collection of really small vortices. But overall, let's say that it's circular.
Yep.
Also, what really is important is that it's converging, and that there is some downwelling, which means that you have some currents that are like kind of diving in the middle, which will make everything that floats go towards the same location. So it's really like the I think the whirlpool is maybe
Right.
the best example, because on top of that you have the Coriolis effect that will make the gyres from the northern hemisphere go in the clockwise direction, whereas the ones from the southern hemisphere are going counterclockwise. So it's similar to
Right.
what you have in your toilet bowl, for example.
Right. Right. And so in short, again, the pollution process really starts mainly on the land. The currents from the rivers and the plastic floating with those currents push them out to sea. And then as they make their way out to sea, the dominating strong currents of each ocean's gyre, right, actually trap the plastic in these large patches. And that's the big issue that we face.
Yeah, exactly.
And then it's a matter of how do we clean up those concentrations of plastic and I guess stop the pollution at the source from the rivers too. And that's where obviously the ocean cleanup comes in. And before we talk about the solutions and how you guys are tackling the cleanup process, one thing that would be really interesting to hear about is your role specifically. So you're a computational modeler, or the lead computational modeler at the ocean cleanup. Can you just explain a little bit about what that means and what part of the process you're involved with in terms of modeling, plastic pollution?
Yeah. So first of all, we need to start, by having an idea about the size, and in terms of space, but also in terms of time that a cleanup actually requires. First of all, it will require a lot of systems, and it will require 10, 20 years to reach the objective that we've fixed in terms of efficiency. And as you can imagine, it's very difficult to know how our systems will perform over time and when put into a fleet. So you need somehow to be able to model that and to extrapolate the performance that we've been observing in the different field experiments that we've been doing into having a 10, 20 years operation. And that's where the computational modeling comes at play. So the objective of my team is to come up with some models to actually predict the efficiency of the cleanup systems based on, the different options that we have in terms of design. And to do that, we've developed what we call a multi-scale approach, because let's say the plastic pollution and the pollution in the garbage patches actually starts at a global level. So when you start, having to come with an answer to this problem, you need to start, understanding how the plastic is actually moving in the ocean. And to do so, since all oceans and rivers are connected with each other, you need to really start at a global level. At this global level, we have ocean models that will give us the velocity of the ocean at the surface. We have source models, which will actually give us an idea of how the plastic is distributed geographically in its sources. So we have let's say different scenarios. For example, we have a coastal scenario, basically based on like the amount of mismanaged waste for different countries, etc. We have river scenarios where we've made an estimation of the amount of plastic that is coming out of rivers. We have an aquaculture scenario where we've made some estimations of the amount of plastic pollution coming out of the aquaculture activities. We have a fishing scenario where we're looking at all the pollution coming out of fishing activities, such as derelict fishing gear and whatnot. We have a shipping scenario because like the shipping activity also yields some pollution. For example, what they call like the containers, the unidentified floating objects, basically. And all that we make it into dispersal models where actually we track all the pieces of plastic and see what's their motion in the globe, and that will lead us to maps of how much plastic density there is everywhere on the globe. And then we also need some measurements to sort of calibrate our estimations. And then once we have these maps of plastics, which are built at a global level, we have some models that will predict how the systems are actually moving in the ocean. So you have on one hand the systems who are moving, then the plastic is moving, and since the plastic collection by the systems is driven by the relative velocity between the systems and the plastic, then we need to understand like what part of the ocean are the systems sweeping. And it will give us, for example, an amount of kilograms of plastic available per week, per year, etc., per system.
Right.
And then they will, as the cleanup, goes on, then each system will remove that much plastic that is removed from the model, etc.
Yeah.
But that also requires to understand, like what's the impact of the system, on the flow of plastic. So, for example, if you have the plastic that is moving by itself and there is no system, it will move in a certain way. If you put the system in the water, then the system itself will disturb the water velocity and can actually, disturb the plastic velocity. So one can imagine that like if the system is moving, then maybe the plastic will try to escape the system. These kind of things. And there we're also modeling what's happening to these current lines once the system is actually impacting the flow of water and thereby the motion of the plastic. So we need to bridge with this multi-scale model. We need to bridge the global scale up to the centimeter scale, which is the scale at which we aim to capture the plastic. So basically, we are looking into plastics, like the lowest threshold in terms of plastic that we aim to catch is the centimeter scale.
Got it. So in summary, basically, or the elevator pitch of your team's role is to use a lot of data to understand where the plastic's coming from, where it goes, and then how efficiently your systems pick it up.
Yeah,
to optimize.
I couldn't say it any better.
Okay, there we go. That's I'm glad that I have a full understanding of that. So before we talk about the design of the systems and the solutions, I want to just stay one step back again. And I think that one of the biggest trends in anything related to the ocean or the blue economy, technology, resources, food, that many people don't understand are the implications that the ocean has on their daily lives. And so making a connection back to someone walking down the street in New York City and how their, health, their job, their, enjoyable climate relies on the health of the ocean is really important. And so with plastic pollution, obviously polluting the ocean is harming the health of the ocean, but it also harms our global economies. It harms our, nutrients in the food that we eat from the ocean, from fish. Can you just explain a little bit more about those, some of those harmful impacts that ocean plastic pollution has on our daily lives, even if it's something that, again, is kind of out of sight, out of mind for a ton of people who, don't fully make that connection?
Yeah, sure. First of all, one of the most striking numbers that one can put, is that we make the estimation that by 2050 there will be more plastic than fish in the ocean. So just to give an idea of how this anthropic pollution, how mankind, which is like one single species, has been able to overcome by its creation, which is plastic, the amount of fish in the ocean by 2050. If things go as they've been going, if the trends keep on going that way, you have like hundreds of marine species that are impacted by plastic pollution. Now 95% of the marine birds have plastic in their body. But then, like, when we say that it's hurting the marine species, is because also on top of the food chain is man. And what happens with plastic, like if you take plastic per se, for example, if you take your Coca-Cola bottle and you grind it and you eat it, nothing will happen to you. The problem with plastic pollution, and particularly what we call the marine plastic pollution, is that the nature of plastic makes it such that it's actually accumulating pollutants, and that the more the plastic is actually makes its way in the food chain, the higher the concentration in those pollutants. So in the end, the fish that men will ultimately eat will actually have all those pollutants concentrated in the end. So that's what I would say to someone in New York City and thinking about throwing it.
Yeah, not
I
aiming
mean,
into the
you cannot
recycling
on
bin.
one hand, like eat sushi, and on the other hand, throw your Coca-Cola bottle in the ocean.
Yeah, right. And so really, one, it's really striking that there's going to be, or there could be, if we don't do something about it, more plastic in the ocean than there are fish in the ocean. And the food supply from the ocean is going to be critical, obviously, to supporting a growing population on Earth. I mean, we have to have protein from fish and other, food sources that are found in the ocean. So it's unbelievably important that we address the issue. And, really the way that you guys break it down, which I think is a really, it outlines the issue very nicely and very simply, is that there's the environmental impact, as you mentioned, of harming marine species in particular from plastic pollution. There's the economic impact that we actually incur, multiple billions of dollars per year from plastic pollution. And then there's also the health impact for us directly. I mean, as those plastics break down, just like you said, and they're consumed by the marine species in the water column of the oceans, we ultimately end up eating those microplastics, and that's not good for our health. So it really directly impacts everyone in one way or the other, which is unbelievable and really important to elevate the effort that you guys are moving forward with.
Maybe one thing I should also mention is that we made a study together with Deloitte on actually the cost of doing nothing, because like for the rivers, that was quite an important effort that we felt like we should be doing, is to actually come up with some numbers of like if you go and talk to governments and you just say, okay, well, buy us that many river cleanup systems, and then they will be okay. Yeah, but if we buy something, then it will cost us something. But then we say, okay, well, maybe it will actually cost you less than the amount that you're already spending on this plastic pollution. And it turns out that there are orders of magnitude between the cost of a river plastic solution and the cost that is currently being, like, in terms of like loss in terms of tourism, and like the amount of money you need to pay to clean the beaches, etc., etc. When you add everything up, then it turns out that cleaning the rivers, having cleaner rivers, is actually a pretty beneficial move that one could make in terms of economics.
Right. And so, we haven't even touched on the solution and how we address this issue. We've been talking about the doomsday scenarios and why it's so important. Which,
well,
I think
doomsday is we're already like getting there. I mean,
we're getting there.
How it is at the moment, the state of how it is already very alarming.
Right. And so that's why, you guys are obviously just now reaching some really critical milestones to start mitigating and stopping the spread, obviously. And so I think timing is good to chat about how you're doing that. And one of the other things that I've been really curious about is, I kind of think about this like a trash can. You have a trash can in your house, and as it gets full, you obviously have to empty the trash can or else it overflows. So the same thing, I would guess, applies here, in that over time, this C-shaped capturing device, passive capturing device, is going to fill up. So how do you remove it and remove the trash or empty the trash once it's filled up the capturing device, and how often do you think you'll have to do that?
Yeah, so basically we were targeting around like every 3 months, 3 months, the emptying of those the retention zone, because we are designing sort of the container that you are mentioning. So it's you need to see it as a kind of a contraption with screens and this kind of thing. So it's not as solid as a normal container, but it's kind of I don't know, sort of a pocket where the plastic would be kept, and also protected from like the harsher times, when you have like very high waves and this kind of thing.
Yeah.
And then the fact that it's in this pocket also makes it quite easy afterwards to be extracted, because if we would have like to sweep the whole area of the 300 meters, that would be quite cumbersome.
Right.
And that's, let's say, one of the main items that we're currently looking at, is how to make this contraption as as efficient as possible and as workable as possible.
And so essentially I would guess you're going to try and pick up this net or bucket out of the water, and with a crane of some kind, and empty it.
Exactly,
more or less. Okay, cool. Yeah. And I would get in the for the rivers, you're basically deploying what you call interceptors, and those interceptors are essentially conveyor belts that pick up trash that's directed straight onto them, and then siphon those into a large dumpster bucket, essentially, that's emptied. And it's close to land, so it's much easier. And probably, you'd have to cycle through that a lot faster, I would guess, in terms of how often you're emptying it.
Yeah, indeed. I mean, it's the sort of the main challenge when it comes to designing cleanup systems for rivers is, first of all, the amount of plastic that is actually flowing in those rivers. So you have some of those rivers are actually having like in the thousands of tons per year coming out of the river. So you might expect like a few tens of tons sometimes per day.
Right.
So
Right.
and then like if you but I'm talking about dry plastic.
Yep.
And if you bring it into volumes, that makes like huge volumes that were required. So the first issue was to make a system that could handle so much waste. And also we wanted something off the grid that was, you need energy for this conveyor belt. And our challenge was to come up with something that would be self-powered in order to be working 24/7 with or without sun. And I'm talking about sun because we're getting all our energy from solar panels.
Okay, gotcha. And so you guys have interceptors deployed already. I'm not sure how many.
Yes,
You already
we have two of them, actually three of them. Sorry, we have one in Indonesia, in the Sanggarang drain. We have one in Malaysia, in the Klang River, and we have one in Dominican Republic, in Rio Osama. And maybe you've seen some of those scary videos of like the sort of waves of plastic that were like crashing in Dominican Republic. And the beach where these footages were taken is actually like next to the mouth of Rio Osama. So
okay, gotcha.
we'll have a living proof that our system is actually has an impact once those beaches will be
cleaned up. Yeah, I've seen the pictures, especially down in Indonesia too, of surfers out in like it literally looks like they're surfing on plastic in the first meter of water. It's amazing, but in a bad way, obviously. And you mentioned earlier, so you have a couple interceptors, 4 interceptors deployed already or built already, and then you have, I believe, deployed the first ocean cleanup system, right?
Well, we've been trying out those up till now. So getting a lot of field experiments, and each time we deployed them alongside a survey vessel that actually costs quite some money. So we would go there for 3 to 6 months and collect some data, and then go back to the drawing board and improve the technology until we're confident that we can deliver on our promise.
Yeah. And so in terms of delivering on the promise, that's a good pivot point. What is the goal? I mean, the goal is obviously to clean up all the plastic in the ocean, but I think your number at the ocean cleanup is 90%. So remove 90% of the plastic in the ocean. How long, and I know that's a huge goal, obviously, right? That's something that you mentioned earlier is going to probably take a few decades potentially.
Yeah.
How long will it take, do you think, to clean up 90% of the Great Pacific patch? Let's just start with where you guys are starting.
The numbers that were, the objective and the numbers that we're playing with, as you mentioned, is 90% in 20 years. So that's the goal. So
and that's the
all
global
the models and all the overall system assessments that we do are based on, like cleaning. The objective, like test several designs. So some designers will say, okay, you need 1,000 of those systems. Some others will be like 60 of those systems, like, for the optimistic ones. And then like we tweak our different design levers in order to match with this objective.
Okay. Yeah. Wow. And so what happens once, I mean, let's say 20 years down the line, you guys accomplish this goal, right? You remove 90% of plastic, but there's still 10%. why not? Is it not possible to remove 100%? I mean, it's obviously not a perfect system, and there's always going to be some pollution, but why 90% and not more?
Yeah, I think, the trade-off, because obviously like having those systems out and like um, uh, running actually costs money.
Yeah.
And it's really a trade-off, like after 90%. So first of all, we're saying that the plastic doesn't disappear by itself.
Yeah.
That's in general, that's true, but overall, if you have 10% left after a certain time, like if we've been able to close the tap, obviously, then this 10% will go away eventually, being degraded, etc.
I
And
see.
like I mean the remaining 10% impact will be much lower than if it were 10 times more.
Right.
So like the economics, and it's really the 80-20 rule. At some point you need to find the right balance, because obviously we won't be able to remove the last bit of plastic in the ocean anyhow. So we
Yeah.
felt that 90% was not only having a dent on the problem, but really like solving a big amount of it.
Yeah. Yeah. Absolutely. And so I guess ideally then you wouldn't have to have the passive ocean-based systems deployed, permanently. But even once you've removed 90% of the plastic from the ocean, that doesn't mean that the rivers will stop being polluted. So the interceptors, I would assume then, would have to be more or less a permanent solution to make sure that you stop that from the source, unless, there are alternatives on land that stop or educate people to stop
I
polluting.
mean, I think it should be a global effort. I mean, we were at the
Yeah.
ocean cleanup. We're definitely coming with a technological solution, because we assume that if we would have to go after like every 7 billion people on Earth, and educate them to prevent really the plastic from being consumed in the first place, or being bad disposed of, then it would be a very, very challenging job. That's and given the urgency of the problem, we felt like using technology to try to solve part of it was the fastest solution. And then obviously, I mean, it would actually give us like 20 years to educate people, because that
Yeah.
one generation, like and then obviously, I mean, like all you have you heard about the DeepSir approach? When you have an environmental problem, you have the driver, which is like the reason why the good that would be creating the pollution is made. So for example, if I take the example of the six ring, the six-pack ring,
Yep.
then the driver would be, okay, well, I want to be able to carry my six-pack to have some drinks with some friends outdoors. Okay, so that's why the six-pack ring was invented. Then you have the pressure, which is the P, is actually ending up trashing and having I don't know, your garbage can is full, and you don't know where to put it. You put it on top of the garbage can. You have some wind that just like makes the six-pack ring, the rings fall on the ground, and then they will end up in the river, and that will create a stress. So it's the S. So it's starting the stress on the ecosystem. And then you have the impact will be actually when your six-pack ring will end up suffocating a turtle, for example.
Yeah.
And we every step the traveling of this 6-pack ring need to be addressed. So you can come up with an action on the driver. So let's not go and have drinks outdoors, which would be, a little bit, hurting our behaviors.
Might be a tough sell.
Okay, we don't need that. Then you have the pressure, which is, like having invented those 6-pack ring in plastic. Well, now there is a company that is actually making edible 6-pack rings, and that's this, and then the rest of the problem is just disappears. So for each step there is kind of a solution. So we're acting on the impact, so a little downstream, but at every step upstream there has to be a solution, and if we can improve things at each of those steps, we believe that eventually, we won't have to act on the impact, because there won't be any impact.
There won't be any pollution. Yeah. Okay. Yeah, that makes sense. So you guys are obviously addressing the end portion of the cycle where the plastic is in the ocean, and then you're also addressing, right? So and then in addition to the ocean, you're addressing the source of the plastic, making it to the ocean with the rivers.
Yeah.
But the source of the source is the land-based solutions that we need to come up with to mitigate and stop the spread.
I mean, at the ocean cleanup, we are not actively working on further upstream.
Yeah.
Because of course we can do a lot of things, and I mean we need somewhat some focus also.
Yeah.
But we believe that the story and the outreach that we've had with the ocean cleanup has some kind of educational strength that would actually help the upstream as well, by just having people know about the problem.
Yeah, I would. I personally have learned a lot from the ocean cleanup. I mean, I know that I work in the industry, and I'm someone who's really passionate about the oceans and care about them, greatly for my own personal benefit. But, I was not aware of the extent of the ocean plastic pollution until you guys really came into the mainstream. And before I actually worked in the industry, I was very familiar with you guys. And I think that many people are in the same boat. And that's really cool to see, the impact that you're having in spreading the word about ocean plastic pollution and how it can be addressed, and why it's cool to address it and why it's necessary to address it. So that's been amazing to watch. And you guys have had an immense amount of traction from that in the last couple of years, at least. So I would say well done on that front. So I guess, we're running out of time. We're already talking, and we could continue to talk for multiple more hours about all the different things you guys are working on. And I think that the end of the story is really that you're solving a huge problem that has global impacts, or contributing to solving this problem by helping to close really what is a deadly cycle of plastic pollution that starts from, different various sources on land and flows into rivers and then gets caught in islands of plastic that float in our oceans. And so I would just highly recommend to anyone listening to go and check out the Ocean Cleanup's website to learn more about, getting educated on how this happens and how they're stopping it with their technology, and, understanding how we can also contribute at an individual level to help mitigate it. Because even though it is out of sight, like we've talked about many times today throughout our conversation, it shouldn't really be out of mind, because it has direct implications on everything that we do on land and our health as a planet, and our, quality of our economy. So, it's been really great to have you on, Bruno, and I really appreciate you taking the time.
Yeah, thank you. Thanks for having me, and it was a great conversation as well.
If you are interested in supporting the Ocean Cleanup, visit their website at theoceancleanup.com. There, you can make a donation or purchase merchandise, including sunglasses made from plastic removed from the Great Pacific Garbage Patch. The best thing you can do to prevent ocean pollution is to stop it at the source by disposing of trash properly or avoiding single-use plastic altogether. Together, we can make a difference in the health and cleanliness of our oceans. As always, we are looking for new ways to bring together those with an interest in our blue planet. Tune in again in 2 weeks to hear from more inspiring entrepreneurs, technologists, and activists who are building the blue vision for the future.